use of electricity. I mean, what data show us that with using ChatGPT versus a search, 10 times more electricity, or that's the common rule of thumb. So for sure, there's more demand. Of course, there will be more efficient cities that will be built in, and the consumption of electricity per search will go down. I can imagine that. In terms of the technology, I've got confidence in the technology that we will be able to roll it out at the speed that is required.
So, yes, AI is everywhere, and we couldn't miss covering that as part of a nuclear energy series. Stay tuned, an interesting conversation is coming up. Hello and welcome to yet another episode of the Mission Shunya podcast, conversations towards the global zero carbon transition. First things first, I hope you're doing well. Over the past few episodes in the nuclear energy series, we have looked at the fundamentals of nuclear science and safety, challenged myths and perceptions, gone inside institutions like the World Nuclear Association, heard from startups like Renaissance Fusion and Novotron Fusion on pushing the frontiers of innovation, and explored how risk is managed with probabilistic risk assessment. It's been a journey across the nuclear landscape, from policy to plasma. And today, as we wrap up the series, we are turning our attention to one of the most pressing and current questions in the energy world. How can nuclear sustainably power the AI revolution? My guest is Ruan Steyn, a nuclear energy expert who has been closely tracking how the surge in digital infrastructure and AI demand is reshaping energy strategies. In this conversation, we discuss why nuclear is suddenly at the center of conversations about powering data centers, how the economics and scalability compare with other options, and what it would take for nuclear to become a trusted backbone for the digital age. On that brief note, let's dive in. Hello, Ron. Welcome to the Mission Shunya podcast. Glad to have you on the show today.
Excellent. Thank you so much for inviting me. It's a pleasure and honor to be on your podcast.
Well, I should say pleasure and honor to have you on the podcast is mine because, well, I started doing the podcast conception and trying to reach out to people. Your name definitely was recommended by a mutual friend. And then I started following your newsletters and you've been writing a lot. So let's look back at your journey from how you got interested in the field and to your role at Sizewell now.
Thank you so much for the kind words. Yeah, been in the nuclear industry back in South Africa, started at a Koeberg nuclear power plant, followed the traditional route on the nuclear fuel side, core designs, safety analysis. The last project I was involved there was on the steam generator replacement. So the nuclear power station is 40 years old, so we needed to reapply for another 20 years of license. So yeah, after that I got an opportunity to come to Sizewell for the new build project. So I moved over to the UK in 2.5 years ago, and currently on Sizewell C project on the nuclear island, looking at the manufacturing of the long lead items and the fuel components. So exciting times, for sure.
Perfect. Now, the topic that I want to cover in this conversation with you is to look at your interest in tracking nuclear as a key part, a key piece in the puzzle when we look at AI's energy demands. So, as demand for energy in the AI space soars, what makes you feel like nuclear energy is uniquely positioned or suited to support the infrastructure?
Good question. I guess what we are seeing and the predictions on the demand for data centers growth-wise, reports by Goldman Sachs and the likes give us expectation of energy demand by 165% by 2030, where AI workloads just seem to continuously grow, and hence the need for electricity and a lot of electricity. What makes nuclear quite unique is the high density element of it. The fact that you can, in a small space of land or piece of land, put out a lot of energy, which is quite ideal actually, positioning these nuclear power stations close to a data center, which these data centers can go up to 1 gig, so one huge nuclear plant next to it, and absorb all the electricity that get produced from that plant. Apart from that, goes without saying, reliable energy 24/7, full year round, and zero carbon footprint, which make it the ideal solution. As we've seen this week with Meta and the Constellation, the Clinton Clean Energy Center, announcing a long-term power agreement. And that's not the only tech. Google, Microsoft, all of them essentially following the same route, looking for stable baseload and a lot of power.
So you did mention that it can be localized, uniquely suited for the demands. But tell me one thing, is it really viable when we talk about small modular reactors or micro reactors near the data hubs for AI data centers? Is it really viable to address the localized energy requirements?
Yeah, these is depending on regulatory approval, of course. It can be done. It doesn't have to be small reactors or micro reactors as such. It can be bigger reactors, as we've previously or earlier discussed. Some of these data centers are quite big energy requirements. The benefit of being close to the data center is, of course, the transmission. Much less losses over the lines, and it's close.
Do you think, in terms of the size and complexity, is it really viable in terms of building it up to kind of meet the requirement?
I think with if one look at, for example, the projected amount of energy required by data centers, there was a recent report from the International Energy Agency which projected something like 945 terawatts hour needed by 2050. So that's a huge amount of consumption by data centers, more than Japan's total electricity consumption. So the need is definitely there, and nuclear is a solution to that, where you have essentially energy security, where your fuel is on site at least for 2 years, or depending on how long the cycle, 2 to 3 years, the fuel is on site, so you don't need to worry about energy security, and the electricity can be produced sustainable without zero emissions. So completely doable, depending on the normal regulatory approvals, of course.
You did mention that the nuclear fuel has to be close to the plant and it stays there for a few years. But the other point is, all the companies that are building these data centers have also pledges to kind of reduce emissions, be a sustainable and environmental conscious company and things like that. So how do you think is like building nuclear power plants and having a sustainable and efficient clean energy future, how does this think align? What role do you think it plays in balancing these two?
I think it's crucial if for meeting those targets, one needs nuclear in the mix to make it. There was a report which essentially demonstrated that without nuclear and expanding nuclear, essentially, it's not possible to achieve the sustainability targets. And I think that is clear from the actions from the hyperscalers. We are seeing that not just the need for having electricity 24/7, but also meeting their sustainability goals. Nuclear needs to be in that mix. It will be interesting to see how it develop from the consumer side, if they are demanding we need our data centers or the data that they use essentially to be from clean energy. That will be interesting to see how that works out. But at least from what we see from the actions of the hyperscalers, it's clear that the realization is that nuclear needs to be part of it.
As a follow-on question to that, do you think that is also a reason why you see a lot of companies directly investing in nuclear companies at nuclear company level, buying stakes into the companies?
Yeah, Ganesh, a good question again. I think what I am seeing is that essentially the hyperscalers on a different timeline than, let's say, the traditional nuclear power plants, how long it takes to essentially go through the application process, environmental studies, building, all of that. I think the traditional way that the new build have gone over the last couple of decades, maybe bar the eastern countries, let's talk only on the western countries. It's clear that the hyperscalers are on a different timescale, and hence by investing and taking stakes or partaking in the supply chain, they are pushing the technology forward. So I can imagine that SMR, AMR, and even fusion is getting a bump in a positive direction with all the capital and resources being deployed into the sector.
Fair. One thing for sure, we know that hyperscalers and things around AI demand is definitely increasing. But the other thing that we often hear less about is the technology for SMRs is also evolving. Do you think there is something that both of them can coexist? Do you think development or demand for AI will actually help the nuclear sector more? Will it benefit that sector in such a way that the safety protocols, the performance requirements, and other things that is typically kind of taking a long time in nuclear will probably be achieved at a faster rate?
Absolutely. And I mean, those are already deployed in the nuclear sector. I'm thinking back of my days on core design, where it's maybe rudimental to what we currently have or the capabilities of today, but it's already being deployed within power stations. I mean, in terms of the regulatory approvals of that, I think there's work that needs to be done there. However, I would say for the almost the low safety equipment, sensors, predictive maintenance, detection, digital twin, those type of areas, for sure, AI will improve those and essentially increase the safety, building of plants with digital twins, potentially reducing the cost that it entails to build these new plants. So for sure, it will be changing the nuclear industry with fusion as well. For example, help simulating the plasma behavior, optimizing the design, improving the controls, all those type of areas. I can see that AI will just push it forward and improve it.
But is it really scalable at a pace where you think, because AI demand is definitely increasing every day because of the number of queries that goes into the system and number of GPUs that are built to kind of address all the systems. So do you think nuclear energy is scalable that way? Because generally nuclear power plants tend to have a long lead time. But even in the case of SMRs, do you think it can really scale up?
Another good question. To your comment on use of electricity, I mean, what data show us that with using chat GPT versus a search, 10 times more electricity, or that's the common rule of thumb. So for sure, there's more demand. Of course, there will be more efficient cities that will be built in, and the consumption of electricity per search will go down. I can imagine that. Your question to nuclear, is it scalable and can it be deployed fast enough? Yeah, that's a big question. In terms of the technology, I've got confidence in the technology that we will be able to roll it out at the speed that is required, or as as predicted by these various institutes, that will be a Manhattan 2.0 scale effort to expand nuclear and roll it out. Not impossible, but it will require big efforts just to keep up with the growth projections. There's several bottlenecks due to just lack of investment in the industry for a number of years. I'm thinking of mining, enrichment, regulatory process, manufacturing components, supply chain, which is in a way fragmented. So a lot of work needs to go in on the ground, essentially to build up a nuclear power plant and doing it faster and continuously, one after the other. It's been done in the 70s, as we know, 70s, 80s in France. So I can't see that we can't do it again. The regulatory environment and many other differences compared to those years. But yeah, doable for sure.
As a follow-up to that, you didn't mention an equivalent of Manhattan Project. But in this space, do you think there is that level of collaboration between the players? Of late, we have also seen companies like, I don't want to mention the name of the companies, but companies have gone burst trying to do this. Do you think the companies are really equipped to do this now? Or do you think they will still face headwinds in kind of getting to product market fit or commercialization?
I think if we speak about the SMRs, for example, keep track of it or try to keep track of it as far as possible. Last time I checked, there's 80 designs. So, I mean, I guess if one look at the Gartner hype cycle with technology and the innovation, I think it's clear that we can't have 90 or 80 designs or different type of reactors. I'm for sure that there needs to be consolidation. Yes, we need that innovation. We're just talking about the reactor type design specifically. But in all elements, massive investment needs to be done on the manufacturing side to ramp up that. I mean, even a country like China, which are building one after the other, they are looking to push it to an even higher level. But you need to rethink how you do in terms of integrating the factories and these different elements of the nuclear build, essentially integrating that into one another. And yeah, we need to build that up from the ground, essentially. So doable, but yeah, a massive effort needed. I think what is encouraging to me with the latest trend that I at least see is other industries are taking an interest in nuclear, which is quite interesting for me. Traditionally, I would say the human resources and nuclear is generally from the same background or similar background, but there's more and more interest from developers. All these different areas are coming into nuclear and saying, how can we support you? You've got a problem that we've solved in other areas or in manufacturing, and transferring that essentially to nuclear, which I think is very encouraging, bringing in new ways of doing and breaking the way essentially that it's been done. Not as something wrong or as it's all not good that have got us here, but essentially innovation is driven via other people coming in the industry and solving the problems and just bringing that energy.
That's fantastic.
Yeah, all interested parties in the industry or even outside of the industry, yeah, please reach out. Or if you've got any questions on nuclear, I think the tide is changing where there's more information coming out on nuclear, and yeah, it's always a pleasure to engage in conversations around nuclear. So please feel free to reach out if there's any questions, or happy to support where I can or draw in from my network where I don't have the capability or knowledge.
So, Ron, before I kind of let you go, I have to ask you now that you are actively working with Sizewell. So, in terms of timelines, every one of the listeners probably by now are kind of aware of what are the active projects that are going on. So, if I were to ask in a neutral way, in terms of timeline, do you think the project will be commissioned in a timeline that is positively surprising or negatively surprising?
Yeah, always a interesting question. What I can say is we are taking all the lessons from Hinkley Point and integrating that into Sizewell. We are seeing some positive already between Unit 1 and Unit 2. Today I did a post on LinkedIn demonstrating some areas which we are seeing already a reduction in time or how long it takes. So for sure, we are working hard to bring that to Sizewell as well, and essentially doing exactly what we have done, which is tricky. Replication, we've got in the organization replication champions, which are looking at designs that to be exactly the same as Hinkley Point. We're controlling that with a no change committee. So the controls is in place to do exactly the same. And with that idea is to do it in a faster timeline. So that is what we do on a daily basis to ensure that it is done safe.
Thanks, Ron. I think you were as neutral as you can on that. So I think you did share some interesting insights on the podcast today. Thanks for taking time to join me on the show. And I definitely recommend your newsletter to all the listeners who want to keep track of all the projects, all the announcements that are happening in the space. So it's definitely interesting. I learned a lot. I continue to learn a lot. So thanks again for taking time to join me on the podcast.
Pleasure is all mine. Thank you so much. Appreciate it. Keep well.
That was Ruan Steyn helping us explore one of the most important questions for the future of both technology and energy: how nuclear can sustainably support the AI revolution. From the surge in data center demand to the unique advantages nuclear brings in terms of reliability and low carbon baseload, this conversation highlighted why nuclear is being revisited not just as part of the clean energy transition, but also as part of the digital transition. And with that, we come to the close of this special nuclear energy series on Mission Shunya. Across the past few episodes, we explored nuclear from multiple perspectives: the science, the safety, the myths, the institutions, the startups, the risk, and finally, its role in powering our AI driven future. I hope this series has helped you see nuclear with fresh eyes, not as a single solution, but as one piece of the bigger puzzle in the global zero carbon transition. And before I sign off, a quick update: Mission Shunya is now ranked among the top energy transition podcasts worldwide by FeedSpot. A big thank you to every listener who made this possible, and thanks to FeedSpot for helping spread the word. So with that, this is Girish Shivakumar signing off on the nuclear energy series of Mission Shunya. And as always, thank you for listening. I'll be back soon.